this video, I'm going to talk about average value. So the average value of a function f of t on some interval a, b really is just asking if I were to take the total quantity that takes place over this time interval a, b and distributed it evenly over that time interval, what would that quantity be? And you can do this visually using a graph. We can see that if I were to sort of level out this function on this time interval AB, I would take some of the higher values up here and dump them down into this hole, and you could sort of draw maybe a dotted line to indicate what that average value is. And this is just an estimation based on the graph, but really all of this upper volume up here would have to measure out and equal the lower volume down here. So how do we represent that mathematically? Mathematically, an average value is going to be the sum of the total quantity under the curve, which is the integral from a to b of f of t, and then I'm going to divide it by the interval of time that has elapsed. And in this case, the difference in time values is going to be the value b minus a. Because this is a fraction, this is sort of a messy fraction, right? A nicer way or a cleaner way to write this is that the average value is given by 1 divided by b minus a, this denominator, times the integral from a to b of f of t dt. And in my head, I'm thinking to myself that this integral represents the total quantity amassed over time over some time interval, and this 1 divided by b minus a, I'm dividing by the time. Typically, when talking about average values, we do this in a contextualized situation, so for a specific quantity over a specific time. One example that you can think about is that of a velocity. And this is an overused example perhaps, but suppose I have some velocity curve, right? This is v of t, and I want to know what is my average velocity from time a to time b. And maybe this is a boring looking curve that visually I can estimate that the average velocity is going to be the velocity value that is the here. Formally, it's going to be the integral from a to b of v of t dt, and I'm going to divide by the total time period that's elapsed, which is 1 over b minus a. But contextually, this is the same thing as the integral under this velocity curve by our net change properties we've already talked about, that this value is going to be the total distance, because the integral of a rate is going to be the total distance that's traveled, and then this divided by b minus a, that's the total time. Let's look at a specific example, and maybe I should say that this is going to be equal to the velocity average over that time interval. Let's look at an example. So in this example, we aren't talking about velocities, we're talking about the rate of water flow through a pipe is given by this function. R of t is equal to t cubed minus 6t squared. And I want to know what is the average rate of flow from t equals 1 to t equals 5. Without drawing a graph, I can know that the average rate of flow is going to be the total gallons in that time period divided by the amount of time that has elapsed. So algebraically, the total gallons is going to be the integral from t equals 1 to t equals 5 of my rate, because the integral of my rate gives me the total quantity. This is my total gallons. And how much time has elapsed? The time that's elapsed from t equals 1 to t equals 5 is 5 minus 1. So 4 minutes have elapsed. So I'm going to divide that by 4. Because this is divide by 4 minutes. And of course, dividing by 4 is the same thing as multiplying by 1/4. So let's compute the integral. The 1/4 stays out front. When I integrate t cubed, that becomes 1/4 t to the 4th minus, I raise the power on t and get t cubed. 6 divided by 3 ends up with 2. And I'm evaluating this from t equals 1 to t equals 5. And so I end up with 1/4 of 1/4 of 5 to the 4th minus, maybe I'll put 2 times 5 to the 3rd minus the lower bound. And the lower bound, I'm going to evaluate the same thing, plugging in t equals 1. That's 1/4 times t to the 4th is just 1 minus 2. And I can plug this into my calculator, and I get